guys, and we are just drawing a right angle triangle. It doesn't matter how big it is. And we are going to label this triangle as triangle ABC. Let's do it like that. Okay. Oh, who is it? It was a mathematician that came up with this rule. Okay, so it's actually a name of a mathematician. Surname, yeah. Okay, his surname was Pythagoras, yes. Now guys, a theorem is basically a rule. Okay, so I think it sounds quite hectic, the theorem of Pythagoras. It basically just is a rule. We've actually worked with some theorems before. So saying that the three angles of a triangle add up to 180 degrees, that's also a theorem. Okay, so it's basically a rule that will work under specific circumstances. Specific conditions have to be met for us to be able to use this rule. Now, guys, we're going to write next to it in a right-angled triangle. Very important. You cannot use the theorem if it's not a right-angled triangle. So we're going to write it out in words, and then I'll explain to you how it actually works. In a right-angled triangle, sorry, the square of the hypotenuse. Sorry about the freezing, right? About it. The square of the hypotenuse is equal to the sum of the squares of the other two sides. Yes. Everyone write this down. Let's highlight the words, I suppose, right angle triangle. Because like I said, you can only use this if it is a right angle triangle. So if you have a right angle, right, if you have a 90-degree angle in the triangle, then we will be able to use this theorem. And that's what we're going to use it for, is actually to find the length of any one of those three sides. But they have to give us the length of the other two. Now, the question was asked, what is a hypotenuse? Does anyone know that? Hypotenuse. It is the side of a triangle that's opposite the right angle. I'm going to write that down now. A hypotenuse is the side that is opposite the right angle. Always, all right? A hypotenuse is always the side that is opposite the right angle, the opposite the 90-degree angle. Now, guys, another thing about the hypotenuse is it will always be the longest side in a triangle. Okay, so we're going to write that as well. Okay, are we fine so far? I haven't really explained a lot, but at least now we know what the word hypotenuse is. Okay, so let me just see. That's what we want to down from that. Yeah, so guys, in this triangle, let's just find the right angle at angle C. Okay? The side opposite angle C is AB. Okay? So that is the hypotenuse. Now guys, we're going to use a different way of labeling our sides, just in case it comes up in a text or exam or even in a textbook. Instead of calling this side AB, you can also call it lowercase c. Alright? So that side, just make it a bit smaller than the c that we used there, so that you can see that it's lowercase. That's another way in which they often label sides. So the side opposite angle C is side small c. Okay? The side opposite angle A, so this one here, we can also call that small a. Okay? And then for the third side also, it's the side opposite angle B. You can use a small b to represent that side. Okay, just in case it comes up in the text or exam or even in the textbook. So lowercase letters are sides usually, all right? If we're talking about this kind of question, a Pythagoras question, the lowercase letters, those refer to sides, and then the uppercase letters, the capital letters, will be the points, right? The angles of the triangle. Yeah. What do you mean? At the end of the yeah. But also, sorry, while we're on that topic, I know you've just done a test. So just quickly make a note, your next test is on the 23rd of September. It's very far in the future still, right? Today is the 17th of August, so it's more than a month in advance. Just write that down so that I don't forget to tell you this. Yeah, you can put it in your phones quickly if that is where you keep your dates. No, it depends on how far we get until that point. So I will still tell you guys exactly what's going to be in that text. Okay. For now, you can just put the date down. Yeah. I think school closed on the 50th. So this is the second last week of yeah, I think it's a Friday. And then school closed the next Friday. Something like that. Yeah, which test when? So guys, this test counts for term 4. It doesn't count for your term 3 mark. But you are going to have a project still in this term. Which I'm not sure what the weighting is yet. Yeah, I don't know what the weighting is going to be. Yeah. I don't know. I'll tell you when I know. It depends on how far we get. Okay, guys, and everyone here, that test actually counts for term 4, but we think it's better to give you the test at the end of term 3 because next term in those 4 weeks or something before exams, all your subjects are going to be testing, right? So that you don't have the maths test also to worry about along with all your other subjects. Let's just get it done with in term 3. Okay, and then next term we'll just look ahead to the exam. Okay, back to this. I'll remind the ABC thing here. Okay. Now guys, what Pythagoras says, let's just read through it again. The square of the hypotenuse. Now the hypotenuse is C. Okay? So what it says there is C squared. That's what it means when it says the square of the hypotenuse. The hypotenuse squared. Alright? C squared is equal to the sum of, what do I do when I'm finding the sum of? Adding the squares of the other two sides. So my other two sides are A, so A squared plus, because they said sum, right? Sum means plus B squared. We are not going to ask you to write this whole sentence out, okay? But you do have to be able to apply it, okay? And when you do use it, guys, just like with the other geometry that we've just done, you need to write a reason. And the reason whenever you use this rule, and we are going to practice it now, so don't stress, but the reason is Pythagoras. Okay, you have to write that reason after. Okay, we're going to do some examples now. So just underneath this, you can write examples. And then you'll see how we actually apply it. Okay, instead of just writing it. Okay, I'm just going to give one heading for all of the examples. I'm not sure how many we'll do. We'll see how it goes. Find the missing link in each of the triangles. Okay, example one. Sorry guys, we are going to have to draw a few triangles now. My apologies. You can just use your ruler and just draw one. Then you can put in the 4 and the 3. Then those are the links. What I'm also just going to do is I'm going to highlight the one that's missing. Okay, you can maybe just use a different color pen and go over that line. Line AC is the one that we need to find. Or what else can I call that side? If I don't want to call it AC, I can also call it small b. Okay, good, because it's opposite angle b. So let's fill that in there. Again, guys, if you want to use this lowercase letter notation, you're more than welcome to. Otherwise, you can just write AC. Okay. Just four. Yeah, you need to be able to adapt to what they're putting in the text. Okay. So we need to find side B or side AC. Now, guys, is that side the hypotenuse? Is it opposite the right angle? Yes. Okay. So this is the hypotenuse. You do actually have to check. All right, because we can use Pythagoras to find any of the three sides. Okay, if we're finding the hypotenuse, you're going to do a specific calculation, which is what we wrote up there. But now, guys, what I want you to notice in the two triangles, I'm just going to go back up to the triangle quickly, right? In this one, our hypotenuse is small b. Was it the same thing in this triangle? No. So you can't just use this formula and say whatever c is, it's going to work. Okay. It's just in this triangle, c was the hypotenuse. In this triangle, our hypotenuse is b. So we need to adapt that formula, that rule. Okay, we need to say d squared in this case. The hypotenuse squared, it's always the hypotenuse squared equals the other two. Very important. The hypotenuse squared is equal to 4 squared plus, what was the other side? 3 squared. And my reason is Pythagoras. Guys, you are not allowed to abbreviate that, unfortunately. You have to write the whole name now. Okay, now we're going to calculate that, guys. What is 4 squared? 16, and 3 squared is 9. What is 16 plus 9? 25. So b squared is equal to 25. If you want to, you can write b squared again. Now I need to find b, guys. What did we do when we were solving equations? What's the opposite of this? I'm squaring something. Square rooting, hey? Do we remember that? The opposite of squaring something is square rooting something. Now, guys, there was something that we used to do that was extra as well. Does anyone remember when we square rooted? Yeah? We did a plus minus. Do you remember?
Yeah.
Then I have a negative length though for side. No. Okay, so I'm gonna write here plus or minus the square root of 25, which is what? Square root of 25 is 5. But because of the context of this question, guys, because we are finding the length of a side, b cannot be negative. Therefore, what is b? 5. And let's just add the word units there. They didn't tell us centimeters or millimeters or whatever, so it's good to just try to do that. It's okay if you leave it out and leave them off, but just if you remember, yeah. Yes, yeah. When you're working with Pythagoras, it will have to be constant. Yeah, because it's always the length of the side. Okay, now guys, those two lines, you don't actually have to write. But it is important that you understand that concept, right? So in a text or exam, you can go straight from b squared to b equals 5. No problem. Full mark. Okay? But we do have to remember, guys, that this was just a normal equation, right? If it didn't have anything to do with a triangle. If they just gave us this equation, solve for b squared is 25. Then you would have to say b is plus or minus 5. Okay. So this you don't have to write, but we must just remember that if it's just an equation, we would have to. Okay, let's just add here. You don't have to write this. Often what I found is because when we do Pythagoras, we don't write the plus or minus thing. Then when we go back to equations, everyone forgets about the plus minus. Okay, so I will keep reminding you guys of that just so that you don't forget. Yes. You just add these together, yeah. So that's 16 and that's 9. So 16 plus 9 is 20. Yeah, just these two lines you don't have to write. You can go straight from that to that. Yeah. Is that fine, guys? If you have to find my hypotenuse, you always write hypotenuse squared is equal to the other two squared, add them together, square root. Okay. Let's do an example now where we actually find another side one that's not the hypotenuse. Okay, so example 2. So we need to be able to do these without the use of a calculator. Okay. So let's remember we must be able to square and we must be able to square root. Yeah. Again. In the next test, yeah, probably not, but I'll just again, it depends on what. Okay, so now we need to find side dx. So when you're done copying this triangle down, just highlight that side. And I do actually quickly want to go back up to the previous example. There was something that I forgot to say. If you didn't want to use a lowercase b, like I said, you can write AC. So if you did it in that way, your calculation here would be AC squared is equal to 4 squared plus 3 squared. Okay, if you wanted to just take the longer name of this one, that's fine. Then in the next line, you would again write AC squared equals 25, and then your answer would be AC equals 5 units. Okay, you can decide. All right, is that fine? Does that make sense? Now for this one, we are finding dx. That is dx the hypotenuse. So, hey, which side is the hypotenuse? DE, which has a length of 13 units. Remember, hypotenuse is always opposite the right angle. Okay, so in this case, we need to find the side that's actually not the hypotenuse. So our calculation is going to be slightly different. Right, what can I call this side instead of DF? I can call it E, small e, okay, lowercase e. But if you just want to call it DF, that's also fine. Now, what you're going to do with, let's just make a note here, not hypotenuse. But remember, what did I write about the hypotenuse at the top? We said firstly, it's the side opposite the right angle, right? The second point that we wrote down is that it's always the longest side in a triangle. So DF has to be a side that's shorter than 13. Okay, 13 has to be the longest side. So do you guys think I can say 13 squared plus 12 squared and then square root it? Let's quickly see what we get if we do that. 13 squared plus 12 squared. I know we're not supposed to use the calculator, but I'm choosing. And then if you take the square root of that, then you get this. If I press SD, that's 17,7. That's longer than 13, right? It can't happen. 13 has to be the longest side. So guys, when you are finding a side that's not the hypotenuse, you always are going to take the hypotenuse squared minus the other side squared. Okay? When you are finding a side that is not the hypotenuse, so E has to be shorter than 13, so I can't plus. I'm going to have to minus. Okay? So when you're finding a side that is not the hypotenuse, you're going to take the hypotenuse squared minus the other side squared. Okay? I'm going to write it down now. So E squared is going to be equal to 13 squared minus 12 squared. Always. If you're finding the hypotenuse, you add the other two squares. If you're finding a side that is not the hypotenuse, you take the hypotenuse minus the other one. Guys, what's going to happen if I swap this around? What will happen if I say 12 squared minus 13 squared? Negative. And is that going to work? Can I have a negative side? No. Okay, so it's very important. Always hypotenuse minus the other one. Okay, I'll write it on the side here. Hypotenuse squared minus other side squared. Let me put that in brackets. Again, we need to be able to do this calculation in our heads. It's a bit more difficult because we're working with bigger numbers. So I will write down that in between step. Do we know what 13 squared is? 169, right? And then what is 12 squared? 144. But that's not too bad, guys. What is, let's do it step by step. 169 minus 100 is 69. Minus 40 is 29. Minus 4 is 25. Okay, so this is actually 25. So again, we are getting an answer for E, 5 units. Right? You do the square root of 5. The opposite of square root something is square root of 5. Yes. Oh, I didn't write my rule. Thank you. I didn't write my reason. Pythagoras. Sorry, I was so fixated on the stuff in red. Let's add that reasoning. Guys, yes. So that's what I'm saying. You don't actually have to write that. Okay, we can just go straight from math to 5. But guys, if this was just an equation solved for E, not with the triangle, then you would have to say plus or minus 5. Okay. The answer is not also, or the answer is not always, going to be 5. Sorry, it just worked out that way in the question. Yeah, will you be able to do a few of these on your own, or if I do another example? These are the 2 questions that you can get though, right? Find the hypotenuse, you add. Find another side, you subtract. Okay, those are the only 2 variations that you can get. Guys, it's very important that you all write this very good. Please make sure that you write this down. It has to be a hypotenuse minus the other one. If you swap them around, you're going to get it wrong. Okay. We have to go check on our studies. So I'm gonna have to give you guys some to practice with me, and so it's here to help. Okay. And the time, well, we'll see now if you do that. It's transformed. The 9, 7, 8. Well, I've tried that, haven't I? Okay. I go yes. Sorry, yes, I'm actually still looking for one. Okay, guys, we are looking at exercise 15.3. I will put it on the board now for your album, but just write that down quickly. Yeah, so you think what? Good. That's the math, the actual one. Okay, guys, I am going to allow you. I am going to allow you to use your calculator for this homework. Thank you. Because some of the numbers are quite big, so it's like 37 and 35, and we won't, if we tell you to not use the calculator, we won't give you numbers that are that difficult to work with. Okay. But if it's like 5 and 8, surely you can do that without a calculator. You would be expected to. Okay, so I'm just going to explain to you now what they mean, because the actual layout of this question is a bit different. Those of you that have a different textbook, it is 179. It's the same text. Yes, I will put it on the board now. Apparently it's on the same page as the other version of the textbook as well. Although maybe this is the other version. I don't know. I have multiple. And the other people that have the other textbook also 179. Right, guys, in number 3, they are asking you to do 4 calculations. Listen up, because you might be confused with the way that this question is asked. They've asked you to do 4 different calculations, but they've given you 1 triangle. Okay? But in A, they're saying find PQ. So they're telling you for A, you need to find that length. And then they're writing in words, PQ is 9 and TQ is 4. Okay, so if you want for 3A, draw this triangle and fill in the values that they've given for that specific question. In B, guys, they're using the same triangle, but they're giving you different values. Does that make sense? And they're asking you to find a different triangle. Yes. You don't have to, it's just going to be because, it's giving you different values. But it's okay, you don't have to. So guys, you are doing all 4 of these. 3A. Yeah. Okay, guys, you can ask sir if you have any questions. Yes. Yes, you can. Yes, Well, we can talk about others. Oh, yes, I. Okay. Thanks, I'll do that. If I can find it. Honestly. No, I'm not gonna record it. Yes. Good luck, man. Thank you. It'll be fine, right? I'm just quite surprised that he chose to go out, but I don't think you realize how good. Guys, so, if I'm not back, can you thank you. Where is that? How's it going, guys? I didn't find him. Someone else found him.